So now let's understand what relations are. Relations are basically a subset of the Cartesian product A cross B that you've just found out. So relation can be anything. Now it can be any certain type of subset of the Cartesian product that you've just found out. So here also exactly the same thing has been mentioned. A relation between two sets A and B is a subset of their Cartesian product A cross B. In simpler terms, a relation describes a connection between the elements of set A, which is the domain. We call the set A, the first initial set, as our domain, and the elements of set B, the codomain. So A is equals to this, B is equals to this. Then any relation between sets A and B would be in this format. Basically, it is just a subset of A cross B. So you need to remember this point only for the time being. And total number of relations between that can occur between A and B. Of course, for A cross B, we know how many elements are there in A cross B. It is going to be P into Q. If there are P into Q elements in this set, and I hope you all remember in sets we had studied, total number of subsets for any set which has m number of elements, the total number of subsets is 2 to the power n. So simply here also total number of relations would become 2 to the power pq. So that is how we arrive to this number here. The number of relations is 2 to the power pq. Now if I was to show you how generally relations are represented. So let me take an example to show you to you. Let's say I have my set A as 9, 16 and 25. And this is my set B. Set B has elements 3, minus 3, 4, minus 4, 5 and minus 5. Now of course we know if I was to find out A cross B, there are going to be 3 into 5, 3 into 6, 18 total terms, right? There are going to be 18 different elements, 9, 3, 9, minus 3, 9, 4. Now for relation, again, it is going to be a subset. So first of all, what I'm doing is I'm defining a condition. I'm defining a condition that B square is equals to A. That means 9 would be mapped to 3, 9 would be mapped to minus 3, 16 would be mapped to 4 and 16 would be mapped to minus 4, 25 would be mapped to 5 and 25 would be mapped to minus 5. So these are the only cases. I'm mentioning this condition here that B square is always equals to A. Now how can I represent my relation? So basically, first of all, the first way is the roster form, which is going to be 9, 3, which is going to be 9, 3, 9, minus 3, 16, 4, 16, minus 4. Then we are going to have 25, 5, 25, minus 5. So these are going to be the elements of my relation, right? Now, what is the other way? The set builder ways of representing my relation. It can be represented as A, B, and this is in such a way that A is equals to B square, provided given that A belongs to set A and B belongs to set B. So this is another way of representing my relation. Now what can be one more way of representing my relation is simply A is related to B in such a way. This is basically an implies sign. Sorry, let me write it down again. This is an implies sign. A is related to B in such a way that A is equals to B square, given that A belongs to set A and B belongs to set B. So these are the three main ways of representing any relation that we have, provided there has to be some conditions. So I hope you must have understood this portion till now. Again, there isn't anything new that we are studying here. Relation is simply a subset of any Cartesian product that we've just found out. And what is that subset going to be? It is going to be a condition that is given to us. Generally in the questions, they provide us with such conditions. Now let's understand what a domain is. A domain is the values that our relation is going to take in the from the first set. So if I was to talk about, let's take this example only. So let A is equals to 1, 2, 3, B is equals to x, y, z, and I'm defining my relation as 1, x and 2, y. So for this, what are my domains? My domains are taken from the first set, which is my A set. So my domain would become 1 and 2. So 1 and 2 has been taken from the first set. So 1 and 2 become my domain. Very simple. Now if we were to talk about codomain is all the values of set B. Now it doesn't matter whether they have been mapped in my relation or not. Here also you can see A is 1, 2, 3, B is x, y, z. My relation is 1, x, 2, y. Still my codomain would become x, y, z. All values of set B are taken as my codomain. So here also you can see codomain of R is B. However, for domain, it used to be only those values that have been taken in my relation. So domain of R is A belongs to set A, given that A, B belongs to relation for some B. That means only 1 and 2 can be taken in my domain. Do not confuse yourself with these two. Domain represents the values that have been taken from set A. Codomain represents all values of set B. Now, there is one more thing which is known as a range. Range is all the values that have been taken from the set B. So similarly, as our domain, it is similar to our domain. The only difference is that all values of domain that are getting mapped in set B, so those mapped values become a range. So here you can see A is 1, 2, 3, B is x, y, z, R is 1, x, 2, y. So here, if you look at this relation only, so my domain is basically 1 and 2. My codomain is going to be my complete set B. So it is going to be x, y, z, and my range would become all those values that have been mapped. So it becomes x, y. X and y have been mapped, so it becomes x and y. So keep these things in mind about domain, codomain, and range, and do not confuse yourself among all these 3 points. Now, if I was to find out the inverse of any relation, what is the inverse of a relation going to be? Simply the reverse. So if, let's say, this was my set A and I was mapping it to set B, if I was mapping it this way, now inverse of a relation means the complete opposite. Now I would have my set B and set A, and I would be mapping my elements of set B to A. So this is, let's say, if this was my relation, this would become my R inverse. So you can see here as well, if R was A, B, then R inverse would become B, A. Now, let's say if I was to find out my domain and range of an inverse relation, and I was to compare it with my domain and range of my normal relation. So how can I write it down? My domain of R is equals to my range of R inverse, and my range of R is equals to my domain inverse. Now again, this simply has a proof which you yourself can do by taking any example of a relation. Let's take this example only, for instance. Here, now what if I map B to A? Of course, my domain would change. My domain would now be 3, -3, 4, -4, 5, -5, right? And my range would become 9, 16, and 25. However, for R, simply R, my domain used to be 9, 16, and 25, and my range used to be 3, -3, 4, -4, 5, -5, right? So now it simply gets reversed. So that is how we get these values. So let us look at this question to get a gist of more as to what relations and inverse of relations are. So R has been given to us. There is a relation where x and y belongs to integers. So again, this is an integer. And we have x square plus 3y square less than equal to 8. So by just looking at this equation, I hope you all must have understood that this is an equation of a ellipse. I know you haven't studied complete details about ellipse till now. It is going to come when we study coordinate geometry. But in your class 12th, you must have seen a little bit of what ellipses are and how are their minor axis and major axes, right? So that is the concept that we are going to use in this question. So this is my ellipse, x square plus 3y square less than equal to 8. So let me convert this into my standard ellipse form. So this would become x square upon 8 by 3 plus y square upon 8 less than equal to 1. So this is how I can represent this standard ellipse, right? I've taken 8 below and I've removed the 3 coefficient from y square. Sorry, this would not be 3 here. There would be a 3 here. So this is my ellipse. Now what if I was to draw the diagram of this ellipse? Of course, you can see that my major axis here, what would be the value of this? This would be 2 root 2 comma 0. And here I am going to have minus 2 root 2 comma 0. So let me make my ellipse first. So this is my ellipse. Here I am going to have minus 2 root 2 comma 0. What would be my b values here? My top value would be 0 comma root under 8 by 3. And here I am going to have 0 comma minus root under 8 by 3. And since it says that all values are less than equal to 1, that means the values that we have to choose, it is going to be inside the ellipse. If let's say you were not being able to justify whether the values are inside the ellipse or outside, simply take the origin. You can see that the origin is inside the ellipse. Put the origin in the equation. Does it satisfy? Yes. If I put 0 comma 0 in this equation, it would satisfy this equation, right? If it satisfies this equation, that means it is lying in my domain or it is lying in my set. That means all the portion which is inside the ellipse would become the values in my set. Now what have they told us? X and y belong to integers. So remember this thing, there are only integers going to be in our relation. And we have to find out the domain of R inverse. So again, finding out the domain of R inverse becomes pretty difficult for us. We have to substitute X with Y. So simply what we'll do is, we'll find out the range of R. As we had seen here, the domain of R inverse is equals to range of R. So let us find out the range of R. Here, X is my first taken value. X is the values that are taken from the first set. Y is the values that are taken from the second set. So range is the values that are taken from second set. And the values through which X can be mapped is my range, right? So from this diagram, what can I see? That my Y belongs from minus root under 8 by 3 to root under 8 by 3. So basically this becomes my range or my codomain. I can say this is my codomain. Now I need to convert this into range. Now how can I do it? I have been told that Y belongs to integers. That means all values that lie in this, all integer values that lie in this range would simply become my answer. So if I was to replace this in terms of, let's say, an approximate integer value, 8 by 3, what can I write it down as? 8 by 3 would simply become 2 point something value which is greater than 2.5, right? 2.5 something. Now I'm taking the root of this. So what would be the root of this? It can be somewhere around 1 point something, right? So it is, if it is 1 point something, sorry, this is going to be plus here, this is going to be a minus here. I wrote it reversal. So 1 point something. So this would be, so this means if it is 1 point something, then later on for root under 8 by 3, it is also going to be 1 point something. So what would be my range? If I was to take in terms of integer, it would become minus 1, 1 and 1. Sorry, minus 1, 0 and 1. Because these are the values that would satisfy this equation. If I put x as y as -1, does it satisfy? Does it come in this range? Yes, it is coming. If I put 0, does it come? Yes. If I put 1, is it coming? Yes. That means this becomes my range of R. -1, 0 and 1. So, and this range of R is basically my domain of R inverse. So this is exactly my answer. So the domain of R inverse is -1, 0 and 1. So this is how you solve questions which are related to domain, range, inverse of any relation. So keep these things in mind.